Hello everyone. Today we are going to continue with our worksheet where we ended. We talked about place value. Okay, we talked about ordering, and also we talked about rounding. Okay. So all this was discussed in class. We discussed about place value, we discussed about ordering, and we talked about rounding. But on this worksheet, we are going to rediscuss them. Okay, now let us continue with dividing by powers of 10, multiplying by powers of 10, and so on and so on. So here we go. Let us keep the borders. Okay, like so. And then yeah, let us start. We have 0.8 divided by 10 power 1. So like as we said, 10 power 1 is equal to 10. So this will be 0.8 divided by 10 power 1 is the same as 10. Okay, so write this as a fraction. This is the same as 0.8 divided by 10. Okay, now 10 has one decimal, 10 has 1 0, so move this decimal point one step on the left hand side, and you put a decimal point over here, and this becomes 0. So you cancel that, this will be 0.08. See that? So 0.8 divided by 10, the answer will be, move a decimal point on your left hand side, the answer will be 0.08. Okay, come to this one. 10 power 5 is 10 times 10 times 10 times 10, 5 times. So this will be 2480. Divide by 10 power 5 means 1, 2, 3, 4, 5. Putting this one as a fraction will be 2480 over 10, 1, 2, 3, 4. 1, 2, 3, 4, 5. This is what it means by 10 power 5. You can cancel this 0, cancel this 0, and then count how many zeros are remaining. We are left with 1, 2, 3, 4 zeros. So count. Okay, let me write this. This is 24.8 over 1, 2, 3, 4. So there are 4 zeros remaining. So you count 4 numbers from your right hand side. 1, 2, 3. The other number will be 0. So this will be 0.0248. That's the answer. Come to this one. 9 divided by 10 power 0. Remember what we discussed? Any number to the power of 0 equals 1. So 10 power 0 equals 1. So this will be 9 divided by 1. 9 divided by any number equals the same number. So any number divided by 1 equals that number. 10 power 0, any number power 0 equals 1. All right, how about 10 power negative 1? We have 0.25 divided by. If you have got a negative index, a negative power, you do reciprocal. This will be 10 to the power of 1. But what is 10 power 1? Any number to the power of 1 equals the same number. So this will be 0.25 divided by 1 over 10. See that? Now to divide by 10 means to reciprocal. 10 goes up, 1 goes down, and this sign changes into multiplication. So this will be 0.25 times 10 goes up, 1 goes down. This will be 10 over 1. Okay, now 0.25 times 10, 0.25 times 10. You just ignore the decimal point, and then you do 0.25, and then put this 0 here. Then count the 2 decimal places, because we have 2 decimal places. So count from right, 2 decimal places, 1, 2. So the decimal point will be here. Cancel that 0, cancel that 0, and the answer becomes 2.5. Can you see that? The answer becomes 2.5. So cancel that, this is 2.5 is the answer. Alright, here we go to next question. Extend the borders like so. Then we are good to go. We have 18 divided by 10 power negative 2. We have negative power, so do reciprocal of that. This will be 10 to the power 2. Okay, and work out 10 power 2 means 10 times 10, so this will be the same as 18 divided by 1 over 10 power 2 is 100. Then do reciprocal. 100 goes up, 1 goes down, like so, and then you're going to have 18 times reciprocal of that, 100 over 1. Then when you do 18 times 100, the answer will be 1800. This is the answer. Okay, how about this one? This one is, we have 4.76 divided by, we have a negative power, do reciprocal, this will be 10 to the power 4, and this will be 4.76 divided by 10 power 4 is 1, 2, 3, 4. See that? Because 10 power 4 means 10 times 10 times 10 4 times, and that becomes 10,000. To divide a fraction, this bottom goes up, the top goes down, and this will be 4.76 multiplied by 10,000 goes up here, 1 goes down. Okay, so here what is remaining is 4.76 times 10,000. You ignore the decimal point, just put the numbers next to each other like so, and then count. There are 2 decimal places over here, so count 2 numbers from here, 1, 2. The decimal point will be here. Cancel these zeros, the answer will be 47600. This is the answer. Alright, we have the other 2 numbers, the other 2 questions left. You can pause the video and try K and try L. But if you don't mind, let us proceed. This will be 0.07 divided by, do reciprocal because that is a negative power, so it will be 1 over 10 to the power 3. So this will be 0.07 divided by, then work out 10 power 3 is 10 times 10 times 10, so which is 1000. So this will go up, this will go down, and this will be 0.07, and this sign will become times. The bottom goes up, the top goes down. This will be 1000 over 1. For multiplication, what we do, we ignore the decimal point, just put the numbers or the digits next to each other, 007, 123, 123. Then count how many decimal places are here. We have 2 decimal places, so count 2 numbers from here, 1, 2, keep a decimal point over here. So these 2 zeros will cancel, and these 2 zeros will cancel, so the answer will be 70. Alright, I hope that helps. Then you can try this at your own and drop me a comment if you won't be able to proceed from that. Otherwise, let me go to next page. Okay, next page is a spider diagram. The question says, work out the missing power in each of the questions in these spider diagrams. Okay, in each part, all the questions in the outer shapes should give the answer in the center shape. Okay, let us put borders. Alright, so this part will be for diagram A. Right, let us start. Work out the missing power. Now this time we don't know the power. It is 10 to the power of unknown, call it x for example. So what do we do? The question is, work out the missing power in each of the questions in these spider diagrams. In each part, all the questions in the outer shape should give the answer in the center shape. Okay. Let us see what it means. Let us try this. What we do, we take 0.8 times 10 to a certain power, call it x. The answer should be equal to 8. So what do we do? Since this is multiplication, so we do the opposite of multiplication, which is to divide by 0.8, divide by 0.8 on both sides. You see that? So you are going to remain with 10 to the power of x. We are looking for the value of x. So this will be 10 to the power of x. Now you can take a calculator and divide 8 divided by 0.8. So if you use mental division, okay, let us use a calculator for example. You do 8 divided by 0.8. See that? I'm getting 10. But what if you don't want to use a calculator? What if you don't want to use a calculator? This will be 8 over 0.8. Now, without a calculator, what do? We remove this decimal point by checking the number of decimal places over here. So we have one decimal place. Now, one decimal place means 10. So you multiply by 10 at the top, and you multiply by 10 at the bottom. Okay, see that? So this will be 10 to the power of x equals to 8 times 10 is 80. 0.8 times 10, ignore the decimal point, copy that number the way how it is, and 10, put just 0 here. So count, you have one decimal place, so count one number from the right, and keep a decimal point over here. So 10 to the power of x will be equal to 80 divided by 8. Now 80 by 8, 1 by 8, 10. You see that? So 10 to the power of x will be equal to 10. But remember what we said? Any number to the power of 1 equals to the number itself. So we can write 10 to the power of x equals to 10. Instead of writing 10, just write 10 to the power of 1. So now, if we do comparison, what do you see? 10 and 10, they are the same. So cancel this, 10 and 10. What is going to remain is x equals 1. Can you see that? So what does it mean? It means that here, the missing power, the question is, work out the missing power. So the missing power here is 1. So you fill up here, is 1. I hope that helps. Now let me do this. See that? Let me do that. Okay, to do that, let me erase this and okay, work out that. So what do we do? 8 divided by 10, 10 to the power of unknown, so keep for example y, equals to 8. See that? Now division is a little bit tricky. Yeah, there's a trick in here. So what we do, when you see a division sign, try to write this as a fraction. 8 divided by, write it as a fraction like this. 8 divided by 10 to the power of y. This will be equal to 8. You see that? Now, can you notice that these numbers are the same? Can you notice that these numbers are the same? So what do we do? This is 8 over 10 power y. Even this number, 8, put it over 1. Can you see that? Good. Then from here, you cross multiply. You cross multiply. It will be 10 to the power of y, cross multiply, 10 to the power of y times 8 will be equal to 1 times 8. Can you see that? Now, I'm looking for the missing power here. So what I'm going to do is divide by 8, divide by 8. You see this 8 and 8 will cancel? You see that? So here, it will be 10 to the power of y. 8 and 8 is gone. 8 and 8 is gone, equals to 1. Now, do you remember what we discussed? Any number power 0, any number power 0, any number power 0 equals 1. So here, using that fact, instead of writing 1, I'm going to put 10 to the power of 0, because I believe that any number to the power of 0 equals 1. So I'm choosing 10. Why 10? Because here I have 10. So this will be 10 to the power of y. Instead of writing 1, I write 10 to the power of 0. Okay? So now, when you reach over here, you do comparison. 10 and 10 are the same. You cancel them, and then you consider that. This is y equals 0. See that? So the missing power, the missing power in this case is 0. So here you write the missing power is 0, and this was 1. Okay, let me do another question from here. Now this time I will go for multiplication. You can pause the video and take notes. Okay, my students know that once I explain this, they pause the video and take note of that. Okay, let me do this one. Let me do this one here. This one here equals 8. Okay, what I'm going to do is 8 times 10 to the power of, say, unknown equals 8. Division is what you write in the form of a fraction, but over here we simply divide by 8 on both sides, divide by 8 on both sides. This will be cancelling. So you're going to remain with 10 to the power of m equals 2. Now by 8, 1, by 8, 10. So this will be 1 over 10. Now, do you remember what we discussed? We said that, can you see this? This is a reciprocal. This is a reciprocal of 10 to the power of negative 1. Remember what we said? If we have 10 to the power of negative 1, this is the same as 1 over 10 to the power of 1. But what is 10 power 1? The answer is 10. So this is the same as 10 power negative 1 equals to 1 over 10. See that? Okay, so in here, 10 to the power of m will be equal to 1 over 10. I'm going to write 10 to the negative power. See that? Then you see that these numbers are the same. So cancel that so that you can remain with m equals negative 1. Negative 1. See that? So here you write negative 1. Negative 1. Okay? Can I do another one for division? Yes, of course. Okay, let me find a space here so that I can do another one for division. Let me do another one for division. This is the question. Let me do this. Equals 8. Okay, good. So 0.008 times 10 to the power of, say, unknown w equals 8. Good. Now what do we do? This is multiplication, so we do the reverse of multiplication, which is to divide by 0.08, divide by 0.08. Cancel that. 10 to the power of w. This you can do it mentally. You know how? You do 8 over 0.008. Now you have 3 decimal places, 1, 2, 3 decimal places, so you multiply by 1000 at the top and you multiply by 1000 at the bottom. Okay, so this will be 10 to the power of w equals 8 times 1000 is 8000. But 0.08 times 1000, the answer is 8. You know the procedure. Okay. Now, this will be equal to, let us simplify. This will be 10 to the power of w by 8, 1 by 8. This will be 1000. See? 1000. Now, write this 1000 as a power of 10. 1000 as a power of 10 means 1000 as a power of 10 means how many tens are there? How many tens are there? How many tens are there? There are 3 tens in 1000. There are 3 tens in 1000. There are 3 tens in 1000. See that? Okay, so here 1000 is the same as 10 to the power of 3. Good, yeah? Okay, now here, these tens are the same. Compare the powers. This will be w equals 3. So over here, you write 10 to the power of 3. Here. Okay? You can pause the video and try this and try this. Or I can give this as your exercise and drop me a message if you fail. All right, this question here, okay, let me do it. Okay, now we are moving to part B. Part B is this one here. We have, let me start with this one here. See that? Okay. We have 3.2 times 10 to the power of unknown. To the power of unknown, say t, to the power of t equals, to the power of t equals 0.32. Okay? Good. So to find the value of t, you need to do the reverse of multiplication. That is divide by 3.2. Divide by 3.2. So this will cancel. So 10 to the power of t equals 2. Now, how do we move from here? Here there is a trick. Suppose you don't want to use a calculator. You want to divide this without using a calculator. So what do? We check where do we have more decimal places. In the denominator, we have 1 decimal place, but in the numerator, we have 2 decimal places. So we go for 2 decimal places. 2 decimal places means 100. So you multiply 100 in the numerator and you multiply by 100 in the denominator. See that? So 0.32 times 100, you know the answer is 32. 3.2 times 100, the answer is 320. So 10 to the power of t equals to, by 32, 1 by 32, this is 10. So the answer is 1 over 10. Now remember what we discussed? We said that 1 over 10, that is a reciprocal. So here we write 10 to the power of t equals 1 over 10 is a reciprocal of 10 to the power of negative 1. So 10 and 10 are the same. So what is the value of t? T equals negative 1. Can you see that? Now, I will be using a calculator if at all a need arises for multiplication. For division, I will use a calculator to save time. I hope I have helped you very much mentally without a calculator. So here we go to save time. Let me choose which one? Let me choose decimals, because most students get confused with decimals. Okay, let me move with this one here. So it is 3.2 times 10 to the power of unknown, say p, equals to 0.32. Okay, this looks to be the same. Okay, divide by 3.2. Nope, I guess this is the same thing. It's the same. Let me do, okay, 1 minute to check. What have we finished? I'm confused somewhere. Okay, 3.2, I got negative 1 here. Okay, I got negative 1 here. Cool. So how about 3.2 times, oh, this one was division. Okay. Then you made a mistake. Let me repeat it. Okay, let me repeat it. There is a mistake somewhere. All right, we have, I wanted to do this one. Okay, we have 3.2 divided by 10 to the power of unknown. Let us say t. That equals to 0.32. Good. Okay. Then this is division sign. So what we do, like as I said earlier, we write this as a fraction. So this will be 3.2 over 10 to the power of t equals 0.32, equals 0.32. 0.32. See that? Okay, now from here you make it over 1 so that you can easily cross multiply. See that? Then this will be 10 to the power of t, 10 to the power of t multiplied by 0.32 equals to 1 times 3.2. Good. All right, so here, how do we move from here? We are looking for 10 to the power of t. So 10 to the power of t should remain alone. So what we are going to do is you divide by 0.32, divide by 0.32. This will cancel. And you are going to remain with 10 to the power of t equals 1 times 3.2 is 3.2 over 0.32. See that? Okay. Then this will be 10 to the power of t equals, now this one I'm going to use a calculator. This is, we have 3.2 divide by 0.32. See that? The answer equals 10. The answer equals 10. But this is 10 to the power of t equals 10. So just 10 as a power, you put it 10 to the power of 1. 10 to the power of 1 is the same as 10. So this and this are the same. So you remain with t equals 1. T equals 1. See that? Okay, so here you write t equals 1. That means the missing power here is 3.2 divided by 10 to the power of 1. This is the answer. Okay, let me do another question. Let me do of decimals first, and I will be mixing division and multiplication so that you can get used to all that scenario. Okay, so we have another question over here. Let me go for, this was division, then let me go for this one here. Let me go for this one here. Okay, 0.32 multiplied by 10 to the power of, say, w equals, because here there is a missing power, equals 0.32. This looks to be easy. Number one is multiplication, and then you do the reverse of multiplication, that is to divide. You do the inverse of multiplication. So this and this will cancel. Oh, this, even this is cancelling. So you are left with 10 to the power of w equals 1. Remember what we discussed about 1 as a power. Any number to the power of 0 equals 1. So here I'm going to choose the number 10. Why? Because here we have 10. So any number to the power of 0, any number to the power of 0 equals 1. So 10 power 0 will also be equal to 1. 10 and 10 are the same, so my w will be equal to 0. My w will be equal to 0. See that? Okay, so 0.32, I did this, so I got 0. Okay, so 10 to the power of 0. Okay, should I say, alright, so you can try the remaining and drop me a message if you need help. Okay, otherwise, should I do another example here? No, I guess they're more than enough. Alright, try those remaining and come back to me if you need help. Okay, now we have this part here, ordering decimals, putting decimals in order of size, putting decimals, arranging decimals from smallest to largest. That is what it means by ordering decimals. So ordering decimals involve arranging decimals from smallest to the largest. Okay, here we go. To order decimal numbers, you must write them in order of size, and this is from smallest to largest. Okay. For example, write the decimal numbers in each set in order of size. Put the boundary, put the borders. Now here let us check which is the smallest of all. Okay, check the first number, it's 5.2, everywhere is 5, everywhere is 5, is 5. So we can't determine it from the first digit. Then move on. This is 5.2. This is 5.2, 5.2. So these are looking to be the same. 5.2, 5.3, 5. But this one is 5.1. So in that case, 5.199 is the smallest. Okay, the next smallest will be 5.2. 5.2 are the same, 5.2 the same, 5.2. So we move to another digit, the third digit, which will be 5.21. You see this? 5.21, 5.20, 5.21. You see? 5.21, 5.20, 5.21. So the smallest is 5.20. But this 0 was not there. I just kept it myself to make you understand. So the next smallest is 5.2. Okay. Now, this 5.19, this is taken. 5.2 is taken. Then what next? We have two other numbers left. Other two numbers are 5.212, 5.219. 5.21, 5.21. 5.21, 5.21, the same. Go to the fourth digit, 5.212, and this one is 5.219. So it means 5.212 is the next smallest, and the largest of all will be 5.219. It's the largest. 5.21, 5.219. Yes, this is correct. Let us move here. 32, same, 32, same, 32, same, 32, same. Okay. The first two numbers are the same. So let us pick the third one. 32.4, 32.4, 32.4, 32.4. Oh, they are also the same. So move to the fourth digit. 32.44, 32.44, 32.42, 32.44, 32.40. Oh, okay. Let me start again. There is a logic here. There is a logic here. 32.4. Let me start with the first three digits. 32.4, 32.4, 32.4, 32.4. They are the same. Okay. Third digit, 32.4. Okay, fourth digit, 32.44. Four numbers, 32.44, 32.42, 32.44, 32.40. Okay, got the idea now. So here we add a 0 so that the number should sound as 32.40, 32.44, 32.42. So the smallest is 32.40, but we don't put 0. 32.40, so this number is taken. We have 32.441, 32.42, 32.44. Yes, after that will be 32.42. Then next, this number is taken. Then we have 32.441, 32.448. So 32.441 will be the next. So this is taken. Then we go for 32.448. Yeah, cool. So this is correct. The last one, this you can try as your homework, and then you can come back to me if you don't understand. Okay, Greg uses the symbol. Oh, okay. Greg is using the symbol. So this symbol, this one means a number is less than. A number is less than. And the other symbol means a number is greater than. Okay, now I believe you know how to compare two decimal numbers. Okay, let us see. For example, 4.07 is smaller than 4.15. Is that true? 4.07, 4.15. Yes, 4.0 and 4.1. See the first two numbers. The first number is the same. In each case, 4, 4. So you can't tell which number is bigger than the other until you move to the next digit. 4.0, 4.1, it sounds like this number is smaller than this number. This number is smaller. Smaller, that means you put that symbol. And it is done for you. Okay, how about 2.167 compared with 2.163? Okay, the first digit is the same, so you can't tell which number is greater than the other. But when you move to the next digit, you have 1 here, and here you also have 1, so you also can't tell. 2.1, they sound the same. So you have to move one step. 2.16, still they are sounding the same. But when you move to the fourth digit, this will be sounding as 2.167, 2.163. So it means this number, this decimal, is bigger than 2.163. See that? And this symbol means bigger. Okay, this symbol means bigger. This symbol means less or smaller. Now, I hope that you had understood. Now, let us go to the question. Write the correct sign in all this. Okay, write the correct sign. 9.2, 9, you see this first number is the same, so you can't tell. 9, you can't tell. But move to the next digit. Next digit is 9.2. This one is 9.0, so it means this number is smaller than this number. This number here is smaller than this number. In other words, this number here, 9.2, is bigger than 9.0, is bigger. So being bigger, you put this symbol, bigger. 2, the first digit is the same. Move to the next digit, you get 2.1. Here you get 2.2. So this number 2.1 and 2.2, 2.1 is smaller than 2.2. So 2.1 is smaller than 2.2. Okay, come here. You have 0, 0, 0. 0.0, 0.0, same thing. Move on. 0.0, 0.07, 0.06. So a 0.07 is bigger than 0.06. So this will be your exercise or your homework. Okay, this will be your homework. Do that. Drop me a message if you don't understand. Okay, here we go. Let me check how many minutes have gone. 43 minutes, no problem. Okay, this one here, we are still in ordering. We are still ordering decimals. Okay, here we have a table with some information. Now let us go through this table. The table you see there shows 6 of the fastest times run by women in the 100-meter sprint. Okay, we have the name, we have the country, we have the date, we have the time taken, each runner. Okay, who is the 4th fastest woman? Who is the 4th fastest women runner? Explain how you worked out your answer. Okay, let me start with explanation. Okay. Oh, sorry, I was offing my fan because it looks to be cold now in my room. All right. Explain how you worked out your answer. Let me start with the explanation. To do this question, in order to determine which runner came the 4th, we need to arrange the data for time. Arrange the data for time in seconds, you arrange them in order of size. Remember this vocabulary. Remember this vocabulary. Order of size. Order of size. Order of size means smallest to largest. See that? So when they say order of size, it means what is the smallest and what is the largest. Okay. Now let me put the smallest here, and I will be going all the way down until I hit the largest. Can you see that? Okay, here we go. Here we go. The smallest time is, we want to check who came fourth. Okay, the smallest, we have 10. The first number is 10, 10, 10, 10, 10, 10. So you can't tell. 10 point. Let us go to the second digit. 10.7, 10.6, 10.7, 10.6, 10.7, 10.4. So the smallest is 10.49. The smallest. The next smallest, so this is taken 10.4. Then the next smallest, 10.7, 10.6. Okay, let us compare those which are having the third digit 6. 10.6, yes. 10.6, 10.6, the same. Okay, go to the fourth digit. 10.65, 10.64. Okay, so 10.64 will come second, 10.64 will come second, and 10.65 will come third. Then we have those with 7, 10.75, 10.74. So 10.74 will come first, and 10.75 will come as the largest. Let me check. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. One number was skipped. Oh, 10.73. We have 10.73. So here we have 10.73 here, and you have 10.74 here, and you have 10.75. Let me check. Looks messy. Let me check. 10.49, 10.49, yes. 10.64, 10.65, yes. 10.73, 10.74, 10. Yes, so we are correct. Every data is captured. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Every single data is captured. So the smallest all the way to the largest. Okay. Now the question is, who is the fourth fastest woman runner? Okay, the first. Okay, who is the fourth fastest? Okay. Who is the fourth fastest woman runner? That means, who is the fourth fastest woman runner? Okay, that means, see, this woman here spent, which woman is this? 10.49. 10.49 is Florence Griffith Joyner. Okay, this woman here took the smallest time. So this was the first runner. This was the first runner. This was the first runner. Okay, because she took less time to complete 100-meter sprint. See, she took only 10.49 seconds. Okay, this followed by this one. This was the second winner. She completed 100-meter sprint in just 10.64 seconds. See that? 10.49 was the first, 10.64 was the second, and then the third winner, the third fastest woman runner, took 10.65 seconds to complete 100-meter sprint. Now the fourth person, or the fourth fastest woman runner, took 10.73 seconds to complete 100-meter sprint. Okay, now who is this? 10.73? 10.73 is here, and who is this person? The question is who. So we are looking for the person. So the person is Sherry Ann Fraser. Sorry for the spelling, but the fourth fastest runner. So here you write the fourth fastest woman, the fourth, okay, woman runner is Sherry Ann Fraser. See that? Yes, that is the one who took less time in the fourth position. And the one, the idea is the smaller the time taken, the faster the runner is. That is what we can say. Okay, now we are going to discuss about something which we call units of measurements. How to put the units of measurement in order of size. For example, it can be given like 50 grams, 50 kilograms, which one is larger than the other. Okay, so when you order decimal measurements, you must make sure that they are all in the same units. You need to remember these conversion factors. What does it mean? It means that for the case of length, we have to, frequently memorize how to convert centimeters into millimeters and vice versa. So the conversion factor is this: 1 centimeter equals to 10 millimeter. Okay, and I think that since primary. So we say the conversion factor between centimeter and millimeter is that 1 centimeter equals to 10 millimeter. And the conversion factor between meter and centimeter is that 1 meter equals to 100 centimeter. And the conversion factor between kilometer and meter is that 1 kilometer is 1,000 meter. For the case of mass, you have to know two basic or two fundamental units, kilogram and ton. That 1 kilogram equals to 1,000 grams. But so many students fail to remember that 1 ton has 1,000 kilograms. 1 ton equals to 1,000 kilograms. For the case of capacity, we have to know in 1 liter there is how many milliliters. Okay, and also you can take note of the following few things. Okay, 1 liter, this L means 1 liter equals to 1,000 milliliter. You can put some few units here, like 1 milliliter equals to 1 centimeter cube. You have to know those stuffs. Okay, yeah, something like that. Okay, let us see the questions. Okay, write the correct symbol. Okay, here we are told to write the correct symbol. This symbol means equals to. This symbol means not equal to. You see, not equal to. Now, we want to do judgment that you have 7.5 meter. There is a box here, and you have 75 centimeter. The question is, will you keep equals to, or will you keep not equal to? Now that needs working. Now what is that working we are looking for from here? You should remember this concept here. When you order decimal measure, you must make sure that they are all in the same units. In the same units is when you can make judgment. Okay. You can see centimeter and you can see meter. What is the conversion factor? The conversion factor between meter and centimeter is that 1 meter equals to 100 centimeter. That is a conversion factor. So we are supposed to change meter into centimeters. So 1 meter equals to 100 centimeters from the above table. How about 7.5 meter will be equal to what? Cross multiply. So this will be 7.5 multiplied by 100, then divide by 1. Okay, what is that then? We have discussed 7.5 times 100. Ignore the decimal point, just put numbers next to each other and then count one decimal place. From the right hand side, count one number. The answer is 750. See that? So 7.5 meter is the same as 750 centimeter. Now the question is 750? Now we'll be comparing 750 here and 75 centimeter. You see, we have both centimeters, so now we can do comparison. Now the question is, write the correct symbol. Now we find that 750 centimeter is not equal to 75 centimeters. So we are done. All right, let me go to next page. On this page, we are supposed to write the correct symbol, either that symbol or this symbol. Remember our discussion? This symbol we said bigger than, and this symbol we said less than. See that? Okay, I hope you remember that quick revision. Now let us compare 4.5 kilogram, compare it with 450 gram. Now you can't do any comparison here because one is a kilogram and one is a gram. So what do? We go back to the conversion factor between kilogram and gram. These are what you have to understand, the conversion factor. Now the conversion factor between kilogram and gram. The conversion factor that 1 kilogram equals to 1,000 gram. Okay, now let us do that. The conversion factor is first change kilograms into gram. So we have to go back to the conversion factor which says 1 kilogram equals to 1,000 gram. How about 4.5 kilogram will be equal to what? Cross multiply. This will be 4.5 multiplied by 1,000 divided by 1. How do we multiply this? This is the same as 45000 Then count, we have one decimal place, so count one number from the right. Keep a dot here. This will be 4500.0. Cut that. So in other words, 4.5 kilogram is the same as 4500 gram. Now, the question is, will you keep bigger than that? This number is bigger than that? The answer is yes. This number, 4500 gram, is bigger than 450. Okay. You can pause the video and try this question. Okay. But before that, let me show this as an example. You have 2.3 kilogram, 750 gram, 2.18 kilogram, 1950 gram. The question is, write these measures in order of size, starting with the smallest. Okay. We can't tell which one the smallest of all until we have same units. Now, same units. How do we make same units? What we do over here is we have kilogram, we have gram, we have kilogram, we have gram. So the units over here are mixed up. So what do? We change these units into one single unit. Okay, let me decide that I'm going to remain with all grams. I'm going to remain with all numbers which are grams, and I'm going to change these kilograms into grams. Okay, so this will be affected, but these two numbers will be the same. Why? They are already in grams. So here we say change all kilograms into gram. Okay, let us change all kilograms into grams. So let me start with this. Before we go to that, we have to remember the conversion factor between kilogram and gram. That 1 kilogram equals to 1000 gram. How about 2.3 kilogram? This will be equal to 2.3 times 1000. You know how to do that mentally, but to save time, let me use a calculator. 2.3 times 1000. See that? The answer is 2300. That is gram. Okay. So we know now that 2.3 kg is the same as 2300 gram. This one will remain the same, 780 gram. Let us see this, 2.18. So 2.18, go back to 1 kilogram equals to 1000 gram. How about 2.18 kilogram? This will be equal to, multiply by 1000. So 2.18 multiplied by 1000, that equals to 2180. Okay, good. So this is 2180, is no longer kilogram, is gram, and this one will be 1950 gram. Okay, now the question is, can we arrange those in order of size, starting with the smallest? So now we will be looking at these grams to arrange these. See? We have 2300 gram. Okay, 2300 gram. We have 780 gram. We have 2180 gram, and we have 1950. So the smallest is 7. The smallest is 780 gram. Next will be this 1950 gram. Next will be, this is 2300. This is 2180. So the next is this, but we don't write that. We write the number given, 2.18 kilogram. Then the last one will be this, but we don't write this. We write 2.3 kilogram. So this is the smallest. We have gone all the way until the largest. Can you see that? Okay, I hope that helps. You can try this and that, but otherwise I'll be back to help you do those questions. Okay, but bye bye for now.